Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 20, 2025, about 6 days ago. The big idea is an all-representation, multi-granularity framework that transfers user, item, and cross-representations together, which delivers sizable real-world gains in industrial ads recommendation. The paper is titled, Large Foundation Model for Ads Recommendation, and as we will see later, the implications for large-scale deployment are quite significant. In short, the system unifies feature, module, and model-level transfer, scales to terabyte-level parameters, and shows consistent lifts like 2.45% higher gross merchandise value across multiple scenarios. Okay, let's look at this Twitter. It illustrates a key aspect of the paper, Large Foundation Model for Ads. Alright, the previous figure set the context for upstream to downstream transfer. Figure 1 contrasts prior practice with the proposed pipeline. The left side shows that existing works extract only a user representation, store it, and use it merely as a feature. The right side adds item representations and cross-representations, which are aggregated, stored, and then used at 3 levels: as a feature, as a reusable interaction module, and as a standalone retrieval model, so downstream tasks gain richer signals and flexibility. So the previous figure highlighted transfer routes. Figure 2 shows the full architecture. A user tower and an item tower produce user and item representations, which feed a mix tower with 2 branches for content tasks and ad tasks. Each branch stacks interaction layers and an MLP with multiple prediction heads, so training spans many scenarios. The ad branch also emits a user item cross-representation that flows to the loss, which then guides the shared towers. So the previous figure mapped the overall architecture. Figure 3 shows how the transferred signals are actually used. The left pathway illustrates feature-level fusion, where a cross-representation passes through an adapter, interacts with downstream features, and feeds the downstream model. The middle pathway presents the Isomorphic Interaction Module, which reuses the upstream interaction plus MLP to combine user and item representations, so structure transfer preserves user-item correlations. The right pathway depicts model-level standalone retrieval using small adapters and cosine similarity for ranking. Alright. The previous figure detailed usage paths across feature, module, and model levels. Figure 4 shows the online loop. A request hits storage, representations are transferred to downstream models, and the foundation model simultaneously infers new user, item, and cross-representations that storage then refreshes. A label arrival triggers weight updates for both sides, which keeps learning continuous. Content streams also update the foundation model, so representation quality remains fresh across domains. So the previous figure outlined the online loop. Table 1 presents the headline online metrics. The table shows that the baseline reached 0.8515 AUC, while the dual branch SUM rose slightly and delivered plus 0.79% GMV. Linear fusion alone barely helped, and removing aggregation hurt, which supports the design choices. The full system achieved 0.8525 AUC and plus 1.35% GMV, so aggregation and nonlinear fusion clearly mattered. Alright, 2 takeaways stand out. Transferring all 3 signals, user, item, and cross-representations, consistently boosts revenue and ranking quality, and multi-granularity usage, feature, module, and model levels is what unlocks those gains at industrial scale. The broader implication is practical. Foundation models can power always fresh, cross-domain ad systems. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.